Namaste. Hello everyone. Welcome to Sthita Pragna channel. Today we are kicking off a brand new series and this is the first episode. And what is that series? This series is going to be the Apache Spark Masterclass. Yeah, you heard me correct. And this is the beginner masterclass. We are going to have intermediate and advanced as well. They are going to be separate playlist, but this playlist is beginner. And what is our first episode about? Our first episode is about modern data engineering foundations, and we are going to talk about in specific about OLTP versus OLAP, data lake versus warehouse, and what is cap theory or theorem and the cloud shift. All right. And if you are already working in this space or just curious about where to start, guess what? You are in the right place. I'm guessing you fall into one of the two groups. Either you are already a data engineer looking to upskill with tools like Apache Spark, or you are someone eager to break into the field and want a hands on, friendly guide to get you there. Whichever camp you are in, this video and this entire series in specific is going to walk you through everything you need to know about becoming a successful data engineer in today's world. So, that being said, let's start with our first segment. And what is that? The origins of data engineering. So, in order to know that, let's rewind. I mean, really rewind to the early 2000s. Back then, cloud computing didn't exist the way we know it today. You had to buy your own hardware, then wait months for servers to arrive, then set them up manually and maintain every bit of it yourself. If you wanted more storage or compute, guess what? You needed a bigger machine, period. That's it. Development cycles were painfully slow. Launching a project could take months, even years. I mean, we are talking about 2000s, but guess what? My first project, which was back in 2012 or 11 ish, we had the same problem. If you had to order a new server, it would have taken 6 months by the time it goes through all the approvals and we get the server. But it was the beginning of something big. And what is that? The rise of hosting and automation. Then came hosting providers like Rackspace and GoDaddy. They simplified the process of going online where you can register domains, provisioning servers, even helping with DNS. This was a huge leap forward. These hosted services laid the groundwork for the cloud giants we rely on today. That takes us to the third segment, which is the cloud era. Now, let's enter Amazon Web Services. In 2006, AWS changed the game. When? In 2006. By launching their cloud infrastructure platform. Suddenly, anyone could deploy apps, store data, and scale without managing physical servers. Netflix was one of the first major companies to go all in on AWS, and the rest is history. We all know that. Today, they use AI driven personalization, massive scale data pipelines, and real time analytics to deliver seamless experiences. And a fun fact, Netflix was one of the pioneers of using Cassandra. If you didn't hear about Cassandra, don't worry about it. We are going to use it in one of the lecture, which is a NoSQL database. We will cover later, as I said. Now, the hero of this particular course, I guess, who is it? Data engineer emerges. So, where does the data engineer come into this story? Originally, data engineers weren't even called that. Do you know that? Do you believe that? They were software engineers, database admins, system architects, all doing bits and pieces of what we now call data engineering. And you might have already observed, if you were looking for jobs in Apache Spark, some of the job positions are still called software engineer. I know, right? As the need for clean, accessible, scalable data grew, so did the role. Today, data engineers handle everything from data ingestion and transformation to real time streaming and pipeline orchestration. So, if you had to do that many things to succeed in this field, what do you need? You need a strong grip on. Let's look at our data engineers toolbox. What do you need to have? Number one, you need to know about distributed systems. Don't worry if you don't know what they are, we will talk about them. And then you need to know SQL and data modeling. Yep. And then you need to know cloud services. And what else? You need to know orchestration tools, one or two. And by the way, maybe at the end of the course or some time, I will go and show you the uh, job positions and what they are looking for a data engineer. And it's not yet there, but some of the position I have seen, and increasingly day by day, they are asking machine learning basics. Why you need to know machine learning basics, I will talk about when we get to the machine learning as well. But don't worry, as I said, we will cover all of this step by step in this series. Now you know what the data engineering toolbox needs. Let's start or just look at the types of databases you will work with as a data engineer, right? That's important because we mentioned you need that as well. Let's learn about OLTP first. What is OLTP? It's online transactional processing. This is used for things like banking and flight booking. We all use that, but we never know what is behind the scenes, right? Think fast. Atomic transactions is the specialty of OLTP. Then we have OLAP, online analytical processing. Analytical, that is very important. This is used for analytical queries. What are analytical queries? Well, basically reporting or aggregations. Those are some analytics that you can perform. These databases, this OLAP databases, they are optimized for reads, not writes. I mean, you can write to them, of course, but they are optimized for reads because these are meant for analytics, which means reporting. Reporting means you will read data from your reporting tools. So these are optimized for reads, whereas these for atomic transactions. Atomic means even small level. Then you have NoSQL databases. Some examples are MongoDB. We are going to set it up as part of one of the lecture. Redis, which is a memory database, and then we said Cassandra. Correct? These are schemaless. They are super scalable and great for handling unstructured or semi-structured data. Okay. Then you have something called NewSQL. Not many might have heard. This is a hybrid of these two, offering the consistency of SQL with the scalability of NoSQL. If you are thinking, what are the some databases? Well, one of them is Google Spanner, and then another one is Cockroach DB. Yep, you heard it correct. The database name is called Cockroach DB. Now, those are the databases that you should be knowing. Here's something to remember. Every database type has trade-offs. Some prioritize consistency, others focus on availability or partition tolerance. That's the CAP theorem in action, something every data engineer should understand. So this is what is called CAP theorem. Got it? Now you looked at databases. What about cloud storages? You need to know them as well, correct? Right? What are some of the examples? The most famous is AWS S3, and then you have Azure Blob, and then you have GCP cloud storage. Am I writing it cross? Yes, I am writing it cross, but that's how my writing pad is. So before these services, companies used to run massive Hadoop clusters for scalable storage. These were not there back then. Most of these are actually based on top of HDFS, Hadoop distributed file system. Now you can store petabytes of data with just a few clicks and pay only for what you use. So now you learned about some of these things. Now what's next? To wrap up this section, not the episode, data engineering is evolving fast. Whether you are building batch pipelines, streaming real time data, or designing analytical systems, the role of a data engineer is more critical than ever. Okay? So you need to remember that. Now let's jump into our next section. In today's data driven world, two of the most important concepts you will hear about are data warehouse and data lake. You will hear them everywhere. Any data engineer position you check in the description, you will see this, either of these, or mostly both of them. While these terms might sound similar, they actually solve very different problems, and together they form the foundation of the modern data ecosystem. And by the way, we use both of these at my work, and pretty much every data engineer project you work in, you will have a data lake and data warehouse. I can guarantee you that. Now let's break down what these are, then let's see why they matter and how they fit into the story of modern data engineering. Now, let's rewind to a time when organizations struggled with a very common problem. What is that? Data silos. Imagine a company with important data spread across dozens of separate databases, each one holding pieces of information, but none offering the full picture because data is stored in them separately. This is where the concept of data warehouse was born. A data warehouse, it acts as a centralized hub, solving the silo problem by collecting and integrating data from all over the organization. But how do we get data from all these scattered databases into one place? That's where the ETL job comes in. Our, you can say, side hero. ETL, extract, transform, load. You might have heard ELT as well. We'll discuss about that later on, but right now let's stick with ETL. Let's walk through a simple diagram, shall we? Let's say you have a database A, and then you have a ETL job. And what this job does is it selects everything from, let's say, a particular table, which is the extract part, and then it transforms, and then it insert into your target, which is the load part, and then you will have your data warehouse. So this is how it looks like. Okay, got it? The first thing is extract. The ETL process, it starts, which you can see here, it starts by connecting to a data source or source database and running a query, often something like select star from, usually not star, you will only select whatever the columns you want, not everything that is in the table. This pulls out the rows of data we need, and then we prepare this data using transform. Maybe we standardize the format, uppercase, lowercase, clean up junk characters, clean up missing values, maybe trim spaces, tabs, or apply business rules so that data from different sources fits together smoothly, like joining. This step ensures our data is usable, joinable, and follows consistent naming conventions. Once you do all that awesome stuff, then the load part. The clean data is loaded into the data warehouse. Now, analysts, data scientists, and business users have one central place to run powerful queries, generate reports, and spot trends, forecast, and all that awesome stuff. And it's very important to note ETL jobs are usually run as batch processes. These names are important. Remember these names, batch processes. They might import data just once or run on a regular schedule, like maybe hourly, daily, weekly. Each batch is designed to run to completion, making the process reliable and repeatable. Most most of the times you will run batch jobs at night, because during the daytime you collect all the data using these transactional databases, because businesses will be running during daytime, correct? So you won't do anything unless you have a business use case where you have to get data every 1 hour. Usually anything that you load into data warehouse, they run at night because businesses will be closed by then. But this is all good. But as the world changed, so did the types of data we needed to work with. Now companies collect not just structured tables like the database tables, but also access logs, audio, video files, sensor readings from IoT devices, Internet of Things devices, and even data streaming, correct? In real time from external services. Now, can the databases handle all these steps? Of course not. That's where the data lakes comes into play. Okay. Think about data lake as a massive, like S3, you can store unlimited data, right? Elastic means you can increase it however you want, you can decrease it however you want. Distributed file system. Here, all your data sources, whether it's relational databases, NoSQL databases, server logs. So let me show you how that would look like if I had to draw. So all your data sources like databases, right? Whether they are RDBMS, relational databases management system, or NoSQL, or whatever it is, doesn't matter. Then you have logs, okay? Then you have media, as I mentioned, like audio, video files, and then you have sensor data from IoT devices. Then you have other services. So doesn't matter. These are all different data sources. Sometimes you will have APIs as well. Correct. Then you will have data lake right here. You will be consuming and putting them in the data lake as is raw. So this is like unified storage. Then from here you can put them in the data warehouse or some feature store for machine learning, and then this for analytics or insights. You see how the flow is, right? This solves the problem of fragmented and siloed raw data, creating a single source of truth where every kind of data can live. The data lake doesn't care if your data is fully structured like SQL tables, semi-structured like CSV or JSON files, or unstructured like images, videos, or audio files. It can handle it all. Yes. Once in the data lake, this raw data can be processed in many different ways. Some of it gets transformed and loaded into a data warehouse where analysts run business intelligence queries and looks for insights. Some goes into a feature store powering machine learning and deep learning models. Some might remain in the data lake available for ad hoc analysis or future projects. One of the most powerful features of data lake is its flexibility. Data can be read, transformed, and saved as new specialized data sets. Think of them as child data sets created from parent source data. This allows you to create curated high value views, join multiple data sets, or even produce different versions for different use cases. Every time you create a new data set, it forms part of your data lineage. Okay, data lineage. Imagine data lineage as a family tree of data where you can always trace back to the original source and understand exactly how each data set was created. That's what data lineage is called. If somebody asks, now you know what it means. This lineage is not just good for compliance or debugging, it's also incredibly useful when you need to recover from mistakes, rebuild tables, or roll back to an earlier version after a bad deployment. Now, let's look at how this all gets organized in practice, shall we? Because looking at practical solutions is very important. In data lake, data sets are typically structured using directories and files. If you ever used S3, you would know that. You might see folders. If you are from Databricks, you would have heard about it. You would see folders for bronze, silver, and gold. And by the way, as part of this series, we will cover Databricks as well, so don't worry about it. So, what is bronze layer? This contains raw, unfiltered source data just as it was ingested. So, think about it as like as it is, however, it was in the source, you ingested and put it there. Nothing else. You didn't touch the data. In silver layer, you will have cleaned and enriched. Enriched, it sounds like fancy, but it just means you enrichment means what? You add stuff to make it awesome. Even in the data, that's what it means. Enrichment means whatever use case you have a data set, you add another columns to it and make it more awesome, usable. Maybe after joining with reference tables or fixing errors. That's silver layer for you. And gold layer, this is gold, high value. Now it is expensive in real time as well. Curated data sets ready for advanced analytics or serving to dashboards. That's the goal layer you have. Okay. So if I had to show you, think of, let's assume that you have this as bronze, correct? In the bronze layer, you have something, an example, customer ratings. Okay. And usually Spark, you will have success files. And then let's assume it's a Parquet file. So usually it starts with part some zeros and then some blah blah blah. If you zipped it with Snappy, you will have snappy dot Parquet. Okay, so you have bronze folder, in that you have customer ratings folder, then you will have these two files. Okay, and if I had to go, you might even have common tables where you might look up a lot. So you might have another folder called common, and under it you might have a table called customers, and similarly you will have success file and then the part file. Now if you look at, then you will have silver folder here. What will it have? Well, it will have a table like coffee orders, correct? This will have maybe data stored in partitions, because every day you might get data for this one. So you will have a folder with the date partition, and under it you will have the part files, the Spark files, whatever it is. And under coffee tables, usually you will have something, a Spark metadata as well. So all that stuff, right? So this bronze folder for raw customer ratings stored as Parquet files, which is a popular columnar file format. That's fast to query and efficient to store. I think we will talk about these formats in one of the videos. And silver folder might contain processed coffee order data organized by date and also stored in Parquet. See, you organized the data in date format. That's not how you might have got it, but uh, you know, coffee orders might have data combining with multiple tables here. Each time you process and refine data, you will create new directories and files, but you always keep a link back to your original raw data. That is part of the data lineage. Now, you might be wondering, how do we actually use this data? Well, big data tools like Spark, Amazon Athena, or even cloud native query engines can directly read formats like Parquet. So some of the formats are famous formats anyways: Parquet, Avro, and R from the data lake. No need to load it into a database first. You don't need to. And behind the scenes, metadata catalogs. What is a metadata catalog? We'll talk about it. An example would be, and by the way, I would like you to note these words down. Even if you don't know at this moment, even if you don't understand when I say them, note them down. Use GPTs to learn more about them, because as a data engineer, um, you will hear these words a lot. Okay, metadata catalog. That is Apache, by the way. Apache Hive Metastore. That is an example of a metadata catalog. So what do they do? These keep track of where everything is, how tables are partitioned, who owns them, and what the schema looks like. This makes it easy to discover and use any data set, no matter how big your data lake gets. Okay, so that's a brief about the data lake. And as a quick bonus, with modern tools, sometimes you will hear about ELT. Remember, I said I will talk about this later on. So, as a quick bonus, I'm going to talk about it. You heard extract, transform, load. Now, this is extract, load, and transform. You were like, what is this magic? Well, it's not magic. Once I explain, you will understand this. In this approach, you quickly load the raw data into the data lake or data warehouse, and then you will do your transformation afterwards. You might be thinking, why would I do that? Well, previously the transformation is done on the whenever you are running your ETL job. If you're running on Spark, transformation is done on Spark. But in ELT, transformation is done on the target. If your database, let's say it's Redshift, then the transformation is done on Redshift engine. So you are offloading your transformation compute to target, which would be Redshift or whatever it is. Got it? This can help with real-time, on-demand, or unbounded big data use cases. Got it? Overall, the key takeaway, what is it? Having source of truth data stored in a central place, your data lake can be one of your most valuable assets. It gives you the flexibility to solve a huge range of problems, rebuild data after issues, and power everything from business dashboards to AI. So, to sum it all up, data warehouses are great for structured business analytics with data cleaned and organized for reporting. And data lakes let you store and organize any kind of data in any format and at any scale. Together, both data warehouses and data lakes are the heart of modern data platform, helping organizations move from raw, scattered data to powerful insights and advanced analytics. That concludes the video. If you enjoyed this so far, this first episode, we are going to have several episodes, awesome episodes. Um, so don't leave the series. Stay sit where you are sitting and watch the second episode as well, and coming episodes. And if you haven't, please take a couple of seconds to like and comment. If you haven't subscribed, do that. That will really help the channel a lot. And so far, I plan to have at least, I guess, in the beginner, we have about 150 to 200 episodes. I'm still recording right now, so that was my plan. There are a lot of episodes, and I'm just saying this is just beginner. Then we have intermediate and advanced. But if I had to do that many episodes, I need your support. Okay, so if you haven't subscribed, please do that. And initially, I thought of putting this on Udemy as a paid course, but then I thought, you know what? Let's put it on YouTube and help as many people as we can for free. So I'm going to keep this free. So please like, comment, and share if possible on LinkedIn as well, and subscribe. That will really help this channel and me adding awesome stuff. See you in the next video. Peace out and love you all.